Okay, I will just give some short comments and ideas related to each of the problems. We will start with tutorial 1A, where we have asked for just drawing free body diagrams. Intentionally we have given real life problems and asked you to draw the free body diagrams. Okay, it is important considering that in real life situations there are certain forces that we may have to neglect, certain forces we have to consider depending on the situation of the problem. Okay, so let us go to the first problem. The first problem is about a bicycle. Let me just draw the bicycle here. I am just going to draw a skeleton of a bicycle here. Okay, so there is a bicycle, and the question that we have asked is, supposing this is stationary, okay, and we need to consider the free body diagrams. Now we want to consider the free body diagram of the back wheel. Mind you, the back wheel will have the chain attached to it. This is the front wheel with spokes in it. Then we have asked for, so let me just list them down. One is back wheel, 2 is front wheel, 3rd is pedal and the gear assembly. Okay, that is this part, and finally just the chain alone. This is the chain alone I want to separate and draw the free body. Okay, so what is to be drawn is the free body diagram. Let us start with the back wheel. Okay, so we will draw the back wheel. Mind you, if we have to do, let us say, a free body diagram, it is important to free the body from constraints and introduce whatever external forces that is applied on it. Okay, in this particular case, if I consider the free body of the back wheel, it has spokes in it, right? It has spokes in it. This particular body will have some mass, and therefore there will be an mg acting on it, and let me call this as mbg, mb being mass of the back wheel. Okay, apart from this external force, I do not see directly any external force acting on the body. It is only at the boundary that we see any interaction at all. Okay, so one of the important things to know in this particular exercise is, when I draw the free body, it involves drawing interacting forces, that is the forces that arise due to this body interacting with the other bodies. This could be the body forces. The examples may be gravitational, magnetic, and so on. The other set of forces are the contact forces that arise due to contact. Okay, let us for now look at this particular thing. What are the points at which there are contacts? We have already taken care of mbg, which is due to the gravitational pull. Okay, there is this ground that the wheel is interacting with, and therefore if I remove this ground from the wheel, if I free the back wheel from the ground, I am just going to free it now and draw the ground over here. For these two to interact, what is the ground doing to this particular body is the question. Of course, there is a contact point, so this is the contact point. What is basically happening is this ground is preventing it from moving the vertical direction. Let us assume that we are only looking at downward displacement. It is the ground is preventing it from moving downward. Also, if there is sufficient friction, it is preventing it from sliding back and forth, and therefore at this particular point this ground is making sure that there is an equivalent force that stops this body from going downward. So let us call this as, let us say we will call this point as A. I am just going to shift mg over here so that it is easy. Okay. There are two forces that come in, one to prevent vertical motion, the other to prevent horizontal motion. So let us call this as AY and this to be AX. Okay. What is this? These are the two reactions that appear due to ground interacting with this. Opposite will be the directions of these forces on the ground. What have we used here? We have used Newton's third law in order to draw this particular diagram. Okay. Okay. Having considered this and have drawn this particular set of forces, we will ask the question, where else is it interacting? For now, let us just remove contact with the brakes. There is also this chain that is attached to it. If you look at it closely in this graph, there is this frame. Let me draw it with another color piece. There is this frame that is interacting at this particular point, right, at the hub, and therefore at this particular point I should be seeing an interaction in terms of this frame resisting the motion of the wheel at this particular point in x as well as y direction, which will give rise to two sets of forces at this particular point, which is due to interaction with the frame. Let us call this as point O, so that we have OX and OY that appear when we remove the frame from it. This should be clearly understood, so that it is possible for us to draw this free body. What other forces could exist? There is also this chain that is interacting with that, and if the chain has to be removed, that will have certain set of forces along this particular sprocket, right. So if, for example, if I just draw this chain must be pulling in such a way that this should rotate when we pedal it, right, and therefore it is applying a force, okay, of this nature, right, or in other words the forces are acting along the periphery of this. One other way of representing this is we remove all this, put them together as a moment acting on it, okay, and let us call this as M acting at O. This completes the free body diagram of the back wheel.